This is MAC 1105, Section 1.5, Part 2. What we're doing here is solving quadratic equations. In Part 1, we solved by factoring and by taking the square root. Now we're going to solve by completing the square, which is not the best way, it's not the easiest way, but it is related to taking the square root. If you remember from the last video, we had something like x minus 5 squared equals 10. How we solved this was to take the square root of both sides, and from there it was very easy. So if we could get the problem into this format, we can continue with the square root method, and that's exactly what we're going to do with completing the square. Now this one's a very special one that I made up. It's very easy to get this one into parentheses squared because this trinomial on the left happens to be a perfect square trinomial. This factors into x minus 4 squared. And how do I know that? Because 4 times 4 is 16, and 4 plus 4 gives me 8. So that factors very easily into this squared binomial. Right now, we are ready to complete that with taking the square root. So in one step, we got ready to solve by taking the square root. Take the square root of both sides. The square root of x minus 4 squared is x minus 4. Remember, when you solve by taking the square root, you must put a plus or minus in front. Now this is the square root of 12, which we can factor tree into 2 times 2 times 3, which gives me a pair of 2's with a 3 staying inside. But we still have to add 4 to both sides because we want to get x alone. Remember, where we put that plus 4 on this right side, we need to squeeze it between the equal sign and the plus or minus. So this becomes 4 plus or minus 2 times the square root of 3. Now that was a very special one that I set up so that this factoring step was going to be very easy for us. But the whole idea on completing the square is if you can get it into this factored form, you should be able to complete with taking the square root. When I look here, I see, okay, let's see if I can go to the squared over here. Well, 2 times 2 is 4, but 2 plus 2 is not 6. That says, nope, I am not ready to go directly to the parentheses. So what I need to do is this. I wrote this as x squared minus 6x plus blank. And you say, what happened to the 4? What happened to the 4 is we move it to the other side. 4 is not the number I want in that position, so get it out of the way. I move it to the other side. So that's my first step on this, is take this number and move it to the other side. And I put plus blank there. So what I'm getting ready to do is actually complete the square. I need to add a number in this blank right here that will enable me to write it as something squared. And it's not magic for what goes in that blank. It's a two-step process. You take half of the middle term, half of 6 is 3, and square it. Remember, we are completing the square, so the number that goes right there has to be a perfect square. And it has to be a special perfect square related to this 6. Don't forget to add it to the other side. Now let's see if this really does factor the way I want it to. 3 times 3 is 9, and 3 plus 3 is 6. So this does factor neatly into x minus 3 quantity squared. And negative 4 plus 5 is 9. And then you're ready to complete by taking the square root of both sides. Square root of x minus 3 squared is x minus 3, plus or minus the square root of 5. Unlike this one over here, there is no factor treeing I can do. All I need to do is finish this by adding 3 to both sides. Remember to squeeze it between the equal sign and the plus or minus. So we end up with x equals 3 plus or minus the square root of 5. And remember, Math Lab will expect you to write it as 3 plus radical 5, comma 3 minus radical 5. Let's take a look at a couple more examples. Same idea, this 8 right here is not the number I want, so get rid of it, move it to the other side. So this is x squared plus 10x plus blank, because we're going to have to add a specific number that will create that perfect square that we need. The 8 is over here, plus blank, and then two-step process. Half of 10 is 5, 5 squared is 25. And if I add 25 to the left side, I add 25 to the right side. Can I factor this? Sure. This is x plus what times itself gives you 25? That's 5, and 5 plus 5 is 10. 8 plus 25 is 33. we are now ready to go through our steps to solve by taking the square root. I call this the downhill part. Once you've done the factoring and you get it into the factored stage, it's all down here from there because it is the solving by taking the square root, which you already know how to do. So this is x plus 5 plus or minus radical 33. Take a look at radical 33. There's no factor tree. I mean, we can do a factor 3 of 3 times 11, but there are no pairs, so that's it. Subtract your 5 from both sides. Squeeze it between the equal sign and the plus or minus. And there you go. What you need is just to practice enough of these. On MathLab, keep clicking similar exercise so you get in the habit of move the number over to the other side, take half of the middle, square it, add it to both sides. So it just needs to become second nature if you do enough practice. Now this one is different for two reasons. One is this 8 has already been moved to the other side, so it's like somebody did the first step for you. But the other thing is we have a coefficient in front of x squared. The first couple of examples we did not have a coefficient in front of x squared because you can't complete the square unless it's plain old x squared. So simple arithmetic, divide everything by 2. Gives me x squared minus 6x. I'm going to put plus blank. 8 divided by 2 is 4 plus blank. So just a little bit of arithmetic to get it set up correctly, dividing by that coefficient in front so that I can complete the square. 2 steps. Half of 6 is 3. 3 squared is 9. Add 9 to this side. This factors as x minus 3 squared because 3 times 3 is 9, and 3 plus 3 is 6. 4 plus 9 is 13. We're ready to solve by taking the square root of both sides. This is x minus 3 equals plus or minus radical 13. Move the 3 to the other side by adding it. Squeeze it in between the equal sign and the plus or minus. And that is your solution because there's nothing we can do about the square root of 13. Let's look at one more example. We're back to where we've got everything on one side, but we have this coefficient of 3. So we're going to divide everything by 3. And yes, we're going to divide by 3 over here. Not that it really matters. I'm just emphasizing that we are dividing everything by 3 because pretend this is a 12 or a 9 or something. We would need to divide it by 3 also. So we've got x squared plus 6x plus 5 equals 0. So we've gotten rid of this coefficient here. And now we're ready to go back to the beginning, which is move the 5 to the other side. And then do your completing the square process. Half of 6 is 3. 3 squared is 9. Add 9 to this side also. We have made this so that it will be easy to factor. What did you square to get 9? 3. And over here, negative 5 plus 9 is 4. We've got it factored perfectly. Now we're ready to solve by taking the square root. We get x plus 3 over here. Plus or minus the square root of 4 is 2. This is the first one we've seen that came out not a radical. But we can still finish solving this by subtracting 3 from both sides. Squeeze it in between the equal sign and the plus or minus. And this gives me this solution. Now that should look familiar because we had one like this with the solving by taking the square root. This is where we have to do the high road and low road. Remember, you must do the high road and low road if there is no radical or there is no I. So the high road is negative 3 plus 2, which is negative 1. The low road is using the minus side. Negative 3 minus 2 is negative 5. So there are your two solutions. And I haven't mentioned it for this video, but you can always go back and check. Put negative 1 in for that x and that x. Do the arithmetic and see if it comes out to be 0. Come back and put negative 5 in for those x's, and it better equal 0. You can use your calculator or you can do it by hand.